Okay, so what we want to talk about is 7.3. And really this is going to be the kind of technique to end techniques for solving quadratics. So this is using the quadratic formula. Okay, so the problem pattern that goes with this is this little theorem, which really says if you have ax squared plus bx plus c is 0, right? The thing I'm stating here, by the way, is really kind of the quadratic formula. So if we have one of these guys, right? It's kind of a quadratic equals 0. Then there's an answer for this that's relatively easy. X is given by, do any of you guys know this formula? Have you heard this thing before?
Yeah.
Maybe not? Okay. So it's given by negative b plus or minus the square root of b squared minus 4ac all over 2a.
Oh, I remember that.
Some of you probably remember this from someplace else. There's a little song to the tune of Pop Goes the Weasel that you may learn to
Was it about a
memorize
dance club
this.
or dance or something?
What?
Mine was like about a dance night or something.
Oh yeah, there's a
Sorry
bunch
for
of
it.
these. They're all horrible.
Okay.
I have too much dignity. And
Sing
that's
it.
saying a lot, right? That I have some
Put
dignity.
it on the internet, Joe.
I have too much dignity to sing the song. No, I'm not singing the song. So if some of you would like to go look up the song and learn it, I would recommend that.
Just say it. Who cares? I want to hear one.
I said it as I was writing it down. It's just, it also goes to Pop Goes the Weasel. I'm not singing it.
You
Nice
don't have to
try.
sing it, just like, never mind. That doesn't matter.
Yeah, that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Put that in your head to Pop Goes the Weasel.
You're
okay?
trying
Really.
so hard not to sing it.
I know.
Sing
No.
No, there was actually
No.
names involved. There was,
Dignity.
like Bob and
Right
Alan
up here.
and
How does
stuff like that.
You. No, that'd be horrible.
Bob and Alan.
No, learn the Pop Goes the Weasel. Okay. So, keep in mind, this only works when you have if this, right? The quadratic formula doesn't work when some stuff's on the left and some stuff's on the right. It's all got to be on the left. That said, it doesn't really care about signage, so it doesn't care whether you move stuff to the left-hand side or the right-hand side.
It'll be the same either
It'll be
way.
the same either way.
And it has to equal 0.
Yeah, it's got to equal 0, and it's got to all be on one side. Cool. All right. Do you want to do an example, or do you want to learn the why? Example? Okay. The song was not on the table. It's still not on the table. I'm still not going to sing it. Okay, so if we had x squared minus 5x minus 6 is 0. Okay, so the first thing you should do upon seeing one of these is what? So you could complete the square on this one, right? Why is this one a good why is this one a good or bad candidate for complete the square?
5x is odd, so it's bad.
The 5's odd, so I'd end up with a fraction, right? But I don't have to divide through by an a yet, right? So at the very least, this is only a medium bad complete the square, right? But I want to use my new toy. So the first thing you should do when you're trying to solve a quadratic formula kind of problem is move everything to one side. Okay, it's already done that. Check, everything's on one side. Now the next thing I should do is sort out what are A, B, and C.
So
So what are the A, B, and C here?
A is 1.
Okay, A is 1, good. B is
-5.
very nice. You've got to keep the negatives with these. So this one is -5, and the C is -6. Okay, then what?
Then you plug it in.
Yeah, then you just write this formula down.
So is the
Okay, so X is, and I'm supposed to have negative B, so that's negative, what's B?
-5.
Very nice, -5. Then I'm supposed to have plus or minus the square root. What's B again?
-5 squared.
Okay, so I get -5, wow, horrible, 5 squared minus 4
4 times 1
times 1 times -6. Okay.
divided by 2 times.
Okay, divided by 2 times 1. Okay, these are oftentimes a little bit ugly, right?
Well, after.
This is the price you're going to pay for not having to remember how to complete this square, right? Or for not having to fight with fractions, you're going to have to pay a little bit of simplification price here. You guys see that?
Yeah.
You're also going to pay a penalty if you can't factor, right? You guys see that? If I could obviously factor this thing,
And then you get the 2.
then I should probably do that, right? You guys see that? Like factoring here would be way easier maybe than doing this. So try to factor for a second. Look at it, think about whether complete the square is the right idea. If it isn't, then go on to this thing, right? So quadratic formula should be your kind of last resort, but it works all the time. So if the other techniques aren't going to give it to you, this one will. Cool?
Every time.
Yeah, this one will work every time. The price you might pay for getting it to work is some kind of weirdness in here, right? This might be hard to deal with. And there's a thing that might happen that we'll come across later where we could maybe take the square root of a negative number. And that's not working. We just have to learn to deal with it. Okay, we'll get there, I promise. So with this one, the next thing I should do is try to simplify, right? Okay, so what things can I simplify easily?
The 2 and then the 5.
Okay, I know, let's see, 2 times 1 is 2, and -5 is 5. And the plus or minus will just chill, right? Okay, now do I know any of the bits in there?
You know, 25.
Okay, so this is all under the square root. -5 squared is 25. Is it positive or negative?
Positive.
Positive. Very nice, guys.
-4. Well, when you multiply it to be positive 20.
Okay, see that? I have to multiply these things together. So what's -4 times 1 times -6?
Positive 20.
24.
24, yeah.
Positive 24.
That's an important.
Okay. So
That's
now,
square root, right?
yeah, that's a square root. Okay, so now order of operations says which of these pieces has to happen first.
Add in 24 and 25.
Okay, I have to add the 24 and the 25, so I get 5 plus or minus the square root of something over 2. What's the something?
49.
49, right? And then I can replace this whole business, right? The square root of 49 is something I know. It's 7. So I get
Who's that?
5 plus or minus, wait, I know the square root of 49,
7.
right? That's 7. And then this is over 2.
So is this so it starts to be like, you're
So would you get 2 different answers?
Okay, so there's 2 different answers, right? So X is 5 plus 7 over 2, or x is
5 minus 7.
5 minus 7 over 2. So this guy gets you what? 6, or x is -1. Okay, see that? Okay. What does this mean?
Parabola.
That my parabola, right?
Your parabola.
Parabol.
The parabola I started with, my x squared minus 5x minus 6,
Is that positive 6 and negative 1?
It is the x-axis.
hits the x-axis at
Negative
-1 and positive 6, which means that I could have factored this silly thing. You guys see that?
Would it be like AC?
You think completing the square is the easier method than this one?
It depends. So completing the square is an easy method when this term is 1 and this term is, and this coefficient is even. If those two things aren't happening, then probably quadratic formula is easier. This one we should have factored though, not using the AC method, but just saying, okay, I had to multiply to -6 and add to -5. That's -6 and +1.
Oh, that's not
You guys see that?
Do we do the fraction way?
Yeah, that's that.
So that'd be x minus 6 times x plus 1 is 0, right? If I factored.
Oh, that's one simpler.
And I would get x is 6 or x is -1, right? You guys see that? So either way, right, there's nothing really new here. But this method works when I can't factor. It also works when I can't complete the square. Well, it works when completing the square would be inconveniently difficult, right? I can always complete the square, it just sometimes gets really horrible. You guys see that? When we do the y part of this, we'll see that this thing actually is completing the square. Like, it's the same formula. What's that?
So like when completing the square is going to give you like a bunch of massive fractions, you'll use this kind of stuff.
Yeah, when completing the square is going to give me some horrible number. Like when I have to divide by, oh, here, let's make one up.
Yeah.
We can just make up an example and try it. Okay, so what makes completing the square horrible? Like I'm just looking to make an example, right? So I've got x squared and x something equals 0.
If A is 1, it makes it horrible, and if the second number is a 2.
Oops, that was supposed to be a 5. Let's make it a 3 because I can draw 3. Okay. You guys agree that this would be particularly horrible to complete the square on?
Yeah.
Because first I'd have to divide the whole thing through by 7, right? And then I'd have to divide 3/7 by 2 and then square that, and that gets confusing and nasty, right? But this is an easy quadratic formula problem because all I have to do is get everything to one side, check, right? Then what?
Then you can just plug in. You have to find A, B, and C.
Okay, so what are A, B, and C?
7, 3, and 1.
So A is 7, B is 3, C is 1.
And then you can just plug them into the quadratic formula.
Okay, so let's try it. So x is
-7.
negative,
Oh, no,
Oh,
3.
no.
It's B, yes, B.
yeah, so it's B, right? So it's -3 plus or minus the square root,
Of B squared,
which is
9. Oh, I guess you could, yeah.
3 squared, right? So I would advise, personally, that you write 3 squared.
So you don't square it.
Yeah, so that you don't accidentally square it twice, and so that you can check, once you've gone through the formula, whether you got everything in the right spot. So 4 and then
Times 7.
times 7 times 1.
Divided
And then
by
divided by
2 times 7.
twice 7. Oh, cool. Good. This is going to highlight another thing that can happen. So let's see. The price I paid for not completing the square was that I now have to simplify some stuff, right? Okay, so what stuff do I aim at? What stuff's easy to simplify?
The 3 squared. Here.
Okay. So let's see, I've got negative 3 plus or minus the square root of 9 minus 28 divided by 14. Okay, so x is negative 3 plus or minus the square root of what? Over 14. What's 9 minus 28?
Negative. Yeah.
Negative 19.
Oh,
Okay,
I mean,
what do we do with that? You guys see the problem?
the negative, or the square root. of the
Yeah, I'm asking what number do I square to get a negative number, right? There isn't one.
You factor the bottom one.
There just isn't one. So the answer to this is
No.
no real solutions. So, what does this mean? And there was a parabola, right?
That's not.
And I was wondering if that parabola hit the x-axis.
No.
Can you guys draw a picture of a parabola that doesn't hit the x-axis?
Just up 1. Negative.
Something like that. So what have I learned about the parabola 7x squared plus 3x plus 1?
That does not hit the x-axis.
Yeah, it just doesn't hit the x-axis. That's not bad, right? It just happened. I just learned something, right? You guys see that? Okay, so when you get a negative under the square root, in fact, that thing, this part of the quadratic formula, this guy right here. What did I just learn?
If it's negative, then it's not hitting the x-axis.
Yeah, if it's negative, there's no real solutions, right? This thing is so special that we give it a name. We call it the discriminant.
Like everything under.
And that's spelled wrong, probably.
Like, if we can clearly see that it's going to be negative, do
Yeah.
we have to keep going?
No.
Cool.
So one thing you could learn from the beginning is to check this thing, right? To quick fiddle out b squared minus 4ac. Because if that's negative, you can just write down no real solutions. If it's 0, what do you write?
Undefined. No.
What's the square root of 0?
0.
Oh, 0.
0, right?
I think
So it hits.
You guys see what it hits the x-axis once, right? Because I get a negative b plus or minus 0 over 2a.
Okay.
You guys see that? So it's possible that I get one real solution,
So it's just a line.
or no, it's not just a
It
line.
just hit the
Can I
x-axis.
Oh, it
draw-
just hits the x-axis. Yeah, yeah. One
Yeah, if I want to draw a parabola that just hits the x-axis once, it looks like this, right?
Right, yeah.
So this picture goes with discriminant equals 0. Yep. That's one real solution. If the discriminant is, this picture goes with discriminant,
No real solution. No solutions.
no real solutions, okay. But the discriminant there was
Negative 19.
negative specifically, right? The discriminant was smaller than 0. And the other picture, what's the other picture, guys?
Undefined.
Or it hits it twice.
Yeah, that's where it hits twice, right? That's where the discriminant is
Above 0.
Bigger than 0, yeah, it's positive. And that gives me 2 real solutions, right? You guys see that? This is my 1 real solution there. These are my 2 real solutions there. And this one, I don't need to circle anything, right? Because there aren't any real solutions. You guys see this? There's one other word of caution I would like to give you on the using of this thing. Okay? It's the other word of caution. I didn't mention it because it's usually a little bit obvious, but what's the problem, say, applying this thing to something like 3x plus 1 equals 0?
We don't have a, we don't have a B.
There's no A.
There's no A.
No A, yeah.
You guys see that?
That's just a line.
So if there's A equals 0, right, which is really what's happening here, what does that cause when I try to fill out the quadratic formula?
You're missing something.
You end up with 0.
Oh, you,
I'm dividing by 0, right? So this thing works really when A is not 0 and this. So really I should write here with A not 0, right? But that's going to break in a much more obvious way, right? I'm going to try to divide by 0. I know that's not allowed. Cool? Good with this?